The population of a small town is modeled by the equation P of n equals the initial P times 1 plus the rate raised in power, where n is the number of years. In 2015, the population was 115,000. If the annual rate of increase was 2.1%, how many years are required for the population to double? So we want to know, when does this population double? Meaning, when will this population be twice the initial? Well, if this is my initial, then we want to get to, when is it 230,000 people? And so I can put 230,000 people over here. It equals 115,000 people. And we know the rate is 2.1%. What we don't know is how many years. That's what we're trying to solve for. Now, this is a really easy division here, because when you divide this, we already know what the number should equal. It should equal 2 because it needs to be double. So when I divide that out, I get that 2 is going to equal, parentheses 1 plus 2.1% raised to the power of n. Now, you could just n solve this if you wanted to, or you could use a graphing technique of graphing the left side as f1, the right side as f2, and looking for their intersection. However, I'll solve it the way it's supposed to be solved, using a logarithm. And if you want to solve an exponential problem and you don't know the power, what you do is you switch to a logarithm. This means that this is my base here, and this is my power, and this here is what I would just call the number. I can switch it to a logarithm and say that log of my base, which would be, if you solve this, you could say 2.1%, you divide that by 2. If you want to change the calculator, it becomes 0.021, like that. And so this value, this base, is 1.021. How did I get that? I said 1 plus that number gave me this. So log base of the number 2 will equal n. So I can just type this in the calculator and see what it gives me. So come over here. Let me erase this out of there. I will say that the log of 1.021, and if you didn't want to type it in that way, whoops, you type that in right here. You could also do 1 plus 2.1% as well in our calculators, and that would do just fine. It'll solve it. And then the 2 right here, whoops, 2 right there, press enter, and it says it'll be 33.35 years, it looks like. Okay, so we come back over here. So I'll write the answer here about, and I'm going to copy this so I don't mess up writing the answer here. Wow, that was a large copy. Shrink this down. About 33, let's get this in blue. About 33.35 years. And I'll check, does it say anything about rounding? It doesn't. So if you want to go full years, it would take a full total 34 years to get there, but with population, it's not like a population only increases on January 1st. It would be progressive throughout the whole year. So I would say this, about 33 and a third years, so it's probably around April of the year you'd get there. Now to check our answer, let's just go all the way back and say, here was our original value. So without even simplifying this, I'll just go to the original, and we're going to look in the calculator. If I would have graphed that and done it this way, I could have got my answer by saying that I know that 230,000 is my first equation. My second equation was 115,000 times 1 plus 2.1%. And I'm going to raise it to the power of x. Okay, something's off there. There we go. Raise it to the power of x. I could graph this way, and I could check. And now they're going to cross at 2,300, so I need to go to something, 230,000. So I'm going to just put in like 250,000 so I can really see the graph. And we know that the answer should be 33 years, so I'm going to go greater than that. I'll go 40 years. So now that I can see actual graphs, you would look for where they intersect, and this should give us the exact same answer as we just previously got. When I do the intersection here, you'll see that it says 33.4 years. This again is the same answer we got earlier, 33.35. Obviously, this is not as exact, but this technique would work as well for coming up with an answer. If you wanted something more simple, you just have to simplify the problem down, and then it would. This part makes this not as simple. So if you simplified everything else, you could do so to get a more exact answer in the calculator.